And what's going to happen is I'm going to point to an element that's up here on the periodic table. And once again, only thing you use, if you want, you use the periodic table up here. Or if you want to grab yourself a periodic table, that's it. And once again, we're going to see who can actually get, or who is going to be the fastest at writing down the electron configuration. Now, what I'm going to do is I am going to jump into this competition myself. And I know you're like, ah, come on, this is like super easy, Mr. Harrelson. You're
If you're pointing to it, that's cheating.
Huh?
If you're the one pointing to it.
Oh, but just because I point to it doesn't mean, like, if I point here, I can still go like, hey, it's that, okay, now let me start writing down the electron configuration. So it doesn't really give me that much of an advantage. Plus, once again, I'm older. You're younger. You're youthful. You got all that great, vibrant energy. You should easily be able to beat me. But what I will do, just to make it fair, I'm going to give you a 10 millisecond head start. Sounds pretty fair, right?
Bro, what's the playground?
all right. 10 seconds. I'm going to give you a 10 seconds. How about 1,001, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to jump in there.
Generous.
Very generous.
That's fair. Isn't that fair?
Yeah.
Can we use any tools at our disposal to beat you?
No, you use the periodic table, the same thing I'm going to have right here as well.
Any knowledge? Work together.
Oh, periodic table is right there waiting for you. Yes.
How do you, like, do we just raise our hand when we're done?
Yep, so what you can do is once you're finished, raise your hand and then, or better yet, because I'm going to still probably be up here right on the board, because once again, you're going to beat me probably. I'm not going to know with your hands up if I'm up here writing the electron configuration on the board. So if that's the case, just say, I'm done, Mr. Harrelson, and I'll turn around, and then we'll figure out who actually won. All right, is everybody ready? Got your stylus or pencil or pen, whatever you're using here. I got my expo marker, and I am ready to select 10 seconds. So I'm gonna count 10. I'm not gonna do that 1 Mississippi, 2 Mississippi. That's way too slow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. All right, here we go. Everybody ready?
Yeah.
All right, let's go with Cesium. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Done! Woo! That was fast.
Are you kidding me?
I am so done. Anybody beat me?
Yeah. No.
No? What happened? Once again, I'm able to beat this young generation. Basically, what I got up here on the board is I've got an electron configuration sitting right there. This is what is known as abbreviated electron configuration. There is the long electron configuration, which would look something like this. Hey, cesium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s1. Yeah, if you look at it, I can save myself a lot of real estate by writing this easy abbreviated electron configuration. Now, before I can have you write the abbreviated electron configuration, there's a couple of things that we got to discuss really quickly. We're going to discuss why this is going to be appropriate, which means we're going to have to talk about this thing known as valence electrons and also what are known as our core electrons. So I'm going to go back to our notes here. Pull up the notes. Let's see what we got going on here. Man, every year, I am so impressed with the way in which I'm able to constantly, every single class, for some reason, I don't know why, I'm able to just every time win. Uh-oh, what's going on here? Why is it on auto-save? Continue, and here we go. Oh, I'm not talk about that yet. As it comes, and here we go. All right, here we go. Let's just point out a couple of things you're going to see in the notes. Where we kind of left off in the notes, we talked about the off-ball principle. What's going on here? So we talked about the off-ball principle, Pauli exclusion principle, and also Hunz's rule. And we went in and started building our orbital diagrams based upon knowing these rules. I just want to point out that in your notes, just in case, hey, I'm studying for the test, I don't really remember what's going on here, I kind of put some pictures in there as well, kind of illustrate the same thing. Hey, off-ball principle, electron needs to go in the first energy level before it can go into the second or the third. Pauli exclusion principle, once again, we gotta have no more than 2 electrons and they must have opposite spins, kind of showing you that here as well. And then also, if we look right here, we got Hunz's rule, that's an example of the orbitals. Hunz's rule simply says that, hey, if we go with adding electrons to equal energies, that 1 electron per orbital. That's kind of showing you there. This slide, once again, this kind of looks at the fact that, hey, what happens as we go up in the values, the energy levels are getting closer together. What happens, you start getting the overlaps that are going to eventually take place. And one of the things I did is I kind of took an orbital diagram and kind of created, showing you like all the different overlaps that are starting to take place there. But that's why we said, hey, no problem for us. Because what we'll do is we'll just write out the electron configuration. And then once we write the electron configuration, we can use that to actually build our orbital diagrams here. So simple enough. And these are just some pictures of kind of how the orbitals might look. So here we go, electron configuration. We know how to write the electron configuration. We already kind of talked about like the formal definition, but all this is just a simpler way of showing where the electrons are located in comparison to writing out that lengthy orbital diagram. We said that it goes from lowest in energy, of course, up to highest in energy. We already looked at how to write the electron configuration, but if you forget, hey, you got this right here in your notes as well. We'll skip over this part here. It just kind of shows you writing the electron configuration, which we're capable of doing. And we're now going on to what's known as our valence electrons. When it comes to our valence electrons, these electrons are important. When we go into the next chapter and we start looking at bonds that are going to start forming, we'll look at Lewis dot structures and bonds, single bonds, double bonds, triple bonds, all those things. The bonds that are going to form between 2 elements are going to be with their valence electrons. These are the things that are extremely important. And the valence electrons, if you look at the definition, it says, hey, the electrons in the outermost energy levels. So when I'm talking about the outermost energy level, I'm just simply saying you count sequentially. In this case, I get to the 3rd energy level on down. These are considered to be my valence electrons. On a test, I can ask, hey, for this element, how many valence electrons do they have? A1, B2, 3. Hopefully they're going to say, well, there's 4 valence electrons that we have here. Once again, it is responsible for the chemical properties and behaviors of that given element. We're going to see in a few that elements that actually belong to the same family have similar, in this case, valence electrons. So for instance, silicon sits right here. If you look at carbon, which carbon sits right on top of the periodic table, carbon has the electron configuration of this right here. 1s2, 2s2, 2p2. And if you look at it, when I say they have similar, well, this has 4 valence electrons here. This has 4 valence electrons sitting right here as well. If you look at carbon's valence electrons. Now, we also have what are called our core electrons. These core electrons are going to be the electrons that are actually in the lower lying energy level. So if you're not a part of the valence, then you're going to be a part of the core in this case. Yes?
Are the valence always the last 2?
It's not going to always be the last 2 because you could have something such as, let's go with maybe iron here. F. No, let's not go with iron. Let's go with, can I look at periodic table? Let's write it past. Periodic table out, so let me grab one really quickly. Let's say that we had something such as bromine. So if I had bromine, then I would go in here and say, okay, electron configuration for bromine, it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p. In this case, it's going to be 4p5. So normally when it comes to valence electrons, what we're going to do is we're going to try to find the highest energy level. So that's 1, 2, 3, 4, 3, 4. Okay, 4. That seems to be the highest. I'm going to take everything on down in this case. I'm going to call these my valence electrons. And therefore that means that this is going to represent my core electrons sitting right here. And once again, the core electrons are not really that important. They're not responsible for the chemical behaviors. But one of the things you're going to always notice about the core electrons is that they're going to have the exact same electron configuration as a noble gas. So for instance, if you look at 1s2, 2s2, 2p6, or excuse me, wrong one. Now look here, erase the carbon here. So I look at this electron configuration right here. That's the exact same electron configuration as neon sitting right here. Just like if I look at bromine, and I go 1s2, 2s2, 2p6, 3s2, 3p6, that means it has the exact same electron configuration as argon. What we do when it comes to writing the abbreviated electron configuration is we make things really easy. We say, hey, you know what? If you want the abbreviated electron configuration for Si, I'm going to take the actual core electrons, which is my noble gas, I'm going to place it in the brackets here, and then I'm just going to list, in this case, what my valence electrons happen to be. Just like right here, my abbreviated electron configuration for bromine, I'll put my argon in brackets, and then I'm going to just pick up 4s2, 3d10, 4p5 as being my abbreviated electron configuration. Now, one of the things you might be saying is like, well, okay, I'm not really saving too much time here, Mr. Olsen. I had to write out this electron configuration, then I got to go to the periodic table and figure out which noble gas has this electron configuration, and then put it in the bracket, then write the abbreviated electron configuration here. Well, in actuality, to figure out what the core is going to be is extremely easy. The only thing you have to do is the following. If I ask you to write, in this case, the electron configuration for Si, the abbreviated electron configuration, which is right there, it's on the board. I'm going to show you what I'm going to do here. Figure this thing out. I would find Si on the periodic table. Here we go. I'm going to run my finger backwards. So until I run into the first noble gas, first noble gas is going to be neon. I would write neon down. Put it in brackets. At that point, I have given the person actually the core electrons. If you want to write the lengthy electron configuration for this thing, you go write out 1s2, 2s2, 2p6. But I'm telling you, hey, neon has that exact same configuration. Don't have to write it out. And then what I'm going to do here, when I look at actual silicon, I'm going to say I already captured up to the first 10 electrons, so I need to just continue on, starting off at the third energy level. So I go 3s2, 3p, 2 in this case. So even if I had something such as bromine, same thing here. If I look at it, I'll go right here, run my finger back. I'm going to run right into argon and put argon in brackets. I'm going to go down and say, okay, let me see. 1, 2, 3, 4. Okay, that's the fourth energy level. So that's 4s2, 3d10, 4p, 1, 2, 3, 4, 5, and I got it. That's it. All you're doing, once again, is just identifying first the element, run your finger backwards, and then, once again, after that, put that noble gas in brackets, and continue on with the electron configuration. So, let's try one really quickly. Write the electron configuration for, what did I go with? Something good. Let's go with 10 Sn. So the electron, the abbreviated electron configuration for 10. All right, everybody finished? I couldn't read that more. My eyes are not that good. What'd you write down?
Parentheses, krypton, 5s2, 4d10, 5p2.
4D what, 10?
10, 5p2.
Looks good to me. Is it okay? Okay, now let me point out what's going to happen. Is in a second, I'm going to have you write some electron configurations, well, abbreviated electron configurations. After writing the abbreviated electron configurations, then you get to play this great game. I love this game. This game is name that element. So I will give you things such as this right here. Maybe something like that. And then what some students will do is they'll go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Oh, you're calcium. I'm not wasting my time. That's way too much energy. I'm just going to go to the S energy level. Let's say 1, 2, 3, 4. That's 2. Oh, calcium has to be the identity that goes along with this electron configuration. Or I might give you an abbreviated electron configuration such as, what can we go with? AR. And then after AR, I might give you 4s2, 3d8. And then you're going to go in and you're going to tell me that this is what element?
Copper.
Let's see. So 1, 2, 3, 4, S2. Then we're going to 1, 2, 3, 4, 5, 6, 7.
Oh, nickel.
Wait, make sure I'm counting right. 1, 2, 3, 4, 5, 6, 7, 8, right? Who said copper? Come on. We can count to 8 now. All right. So what's going to happen is you're going to go ahead and work on this right now. So kind of get started on your homework. Your homework is going to be to complete pages 5 and also, actually page 6 and also page 7. 6 is the abbreviated. Page 7 is going to be identify that element.